Alright, so let's look at this second problem that we have. We clearly have the same problem here with the decimal side and with the fraction side. We're first going to look and try to solve it with some decimals. Alright, no problem. We're going to change our fractions all to decimals. However, I notice there's going to be a problem. 2/3, if I were to divide 2 by 3, when I start to do it, 3 can't go into 2. So I'll put my decimal, I'll add my 0. 3 goes into 20 6 times. 6 times 3 is 18. I'd subtract, I'd get a 2, bring down another 0, and notice I get 20 again. 3 goes into 20 6 times, which would be worth 18, which would get that 2, and so I'm going to have a repeating decimal. And we have learned that if it's a repeating decimal, you do not solve it with decimals. Therefore, for this problem, I'm going to do it exclusively with fractions. So my first step as I look at the fraction side is I'm going to change anything that's not a fraction into a fraction. So we have -3/5 plus, this would be 8/10 minus 6/10 times 5 minus 2/3. Now remember, when we start doing our order of operations, we don't just naturally get everything to a common denominator because we don't need that until we're adding and subtracting. Instead, we just start off and see, are there any parentheses? Right here I see some. So it's 5 wholes minus 2/3. If I set up that problem, it will look like this. Well, right now 5 has no thirds. So I'm going to have to decompose the 5 to a 4, give 3/3 up top, and now I can do the subtraction. 3 minus 2 gives you 1/3, and 4 minus nothing gives me 4. So the answer is 4 1/3. Now we bring down everything else we haven't used yet. Next, we look for any exponents, but there's no exponents. So we get to move on to multiplication and division. We see a multiply right here. So we have 6/10 times 4 1/3. So there's a few tips I would give you. First of all, 6/10, both of these can divide by 2. It's normally easier if you use fractions in their simplest form. Second, we don't want a mixed number. We want fractions greater than 1. So 4 times 3 is 12 plus 1 would give me 13/3. Now we're ready to multiply these. 13 times 3 is 39. 5 times 3 is 15. And I know 15 can go into 39 2 times, which would be minus the 30, and 9/15. Now 9/15 can simplify. I can divide both of those by 3, and it would give me 3/5. So the answer to that multiplication problem is 2 3/5. Now I might find later I want to put it back into a fraction greater than 1, but right now this is good. So now I bring down everything I didn't use. At this point, I'm done with multiply and divide. I'm on to add and subtract, and I'm going to take the first add or subtract I see, which is this one. So when I go to do this, I notice that they do not have the same denominator. However, if I do 5 times 2, that would be 10. So the common denominator here is going to be 10. So this is now -3/10, or sorry, not 3. -6/10 plus 8/10. Now these have different signs. We know with different signs we actually subtract them. So 8 minus 6 would give us 2. This will be 2/10. And it will take the sign of the bigger number. The 8 is bigger, so it will stay positive. And then we bring down what we have not used, minus 2 3/5. It seems at this point it might be wise for us to change that fraction, the mixed number, back into a fraction greater than 1. And so when we do that, we know that 2 times 5 is 10, plus 3 gives us 13. I can think of this as 13/5. 2/10 minus 13/5. However, I'm going to need my common denominator. So just like the last problem, I can change it up to tenths, or I could notice that since 2 can divide by 2 and 10 can divide by 2, that this can actually be seen as 1/5. So I'm going to erase that because I think I might be running out of room, and I'll change it to 1/5. Now I do see that I have a minus here, so I'm going to do additive inverse. And now I notice they have different signs. So again, I'll subtract. 13 minus 1 would give me 12. Take the sign of the bigger number, in this case it's negative 12/5, which I could also write as 2 and 2/5, and don't forget my negative sign.